of complying with any. Okay, thank you very much. We'll record. So at any rate, it's more to help think about what you could do, what possibilities are out there, rather than what you're trying to comply with to get a Level 4 or 5 rating. Did that pop out? That popped out. There we go. So let's think for a minute about the framework. Actually, January 15th of next year is the 30th anniversary of CMM 1.1, the Capability Maturity Model for Softwares. When we first released it from the SEI, 1.0 was really just sort of an opening draft to get people to review it and respond to it. And we took all that in, and out of that came 1.1, which was what we released on January 15th of 1993. Quite a while ago. So these are the four models that I know rigorously follow the process maturity framework, the one that Watts originally formulated and that we've improved and matured over the years. There may be others, but these were the four primary. You know, DoD came in and took CMM and their system engineering maturity model and put them into CMMI, CMM immigration. Based on lots of requests we were getting at the SEI, Bill Heffley, Sally Miller and I put together the People's CMM, and Charlie Weber and I had a contract from an international bank to build a true maturity model, but that was focused on business process, on expanding this to the entire enterprise. So that's now a standard with the object management group. But there's also been a lot of others maturity model. We'll call them YAMs, yet another maturity model. I mean, there literally are hundreds of these things. Google can't keep up with all of them. In fact, Google would probably crash if it tried to. But there's a lot, and this is only a small smattering of what's out there. Some of these just say, hey, here's 5 levels and that's it. They don't have practices. Some of them have practices. Most of them typically follow the continuous version, which is here's some number of practices and here's 5 levels for each practice. So I'm not sure how many of these work, how many of them are even used. But the important thing for some of them is that they're proposed by university professors and they can publish them and then they get tenure. So that's really important for a maturity model, is that it can guarantee tenure. So this is some data I collected back in the early to mid 1980s when I was at ITT, back when it was the 5th largest company in the world, and they had a big telecom operation that was half the company, but they also had Sheraton Hotels and Hartford Insurance and Burpee Seeds and the publishing company for Raggedy Ann and a bunch of other stuff. And we were tasked with collecting productivity and quality data across the whole company, and we reported annual productivity baselines. The quality data was such a mess, we could never get a baseline out of it. We tried to work with them to start getting good quality data, but and it took us a long time to get productivity measures to the point that they could be compared. We had to get people counting their lines in a consistent way. That's what we were using back then. But what you can see here is we also ask questions about what software engineering practices are you using? And we had a whole list, and they check off the ones that they were using in regular practice. Well, you can see down here, if they weren't using very many practices, lo and behold, they stunk. Their productivity was terrible. But for those that were using lots of practices, sure, some of them up here were doing great, extremely productive. But there were still folks down here at the bottom that were using lots of practices and getting essentially no benefit from it. And the question is, why was that happening? And I really came to understand that when I went to MCC in 1984, and Watts saw the work we were doing on the design process when he had started at the SEI, and he asked me to be on his advisory board and help. And he and myself and some other folks worked with Watts to help him think through what a maturity model was and what these stages were, because he had the ideas, but he just wanted to try to flesh it out and try to get it clear what it was. And as we were going through it, it became clear that the folks down here at the bottom, the folks that are getting no benefit from all these practices, were folks that were being given schedules they couldn't achieve. They were not given the resources they needed. They didn't have the training they needed. They were basically a level one mess. And so you can give them practices and all kinds of wonderful tools and languages. It's not going to make a difference until you get them out of the soup. They're stuck in the mud because they can't possibly get done what people expect them to get done. And so that really kind of grabbed my attention and helped me understand and really buy into the concepts behind the maturity model. So this is sort of the history of it. It started with Phil Crosby's Quality Management Grid. He published this in his famous 1979 book, Quality is Free. And Phil had a quality college down in Sarasota. I'm sure Pat's down there teaching it now. And Watts went down to the college just to learn more because he was getting more responsibility for helping move more quality practices into their large and far-flung software operations. So Watts went down, listened to the model, got very excited about it. And as he was flying back to New York, to his IBM office up in New York, he had to change planes in Atlanta. And he said that's where the CMM was born, because he sat there waiting for his other plane to show up. And he suddenly realized that quality grid is never going to work. We've been doing things like that in IBM for 20, 30 years, and it doesn't work. It either the practices either fade away over time or they really never get fully adopted. And so something's wrong. The concept that I can have 6 practices and 5 levels for each one of them and will slowly move up that chain just doesn't work very well. So Watts sat there and thought about it and realized, the real issue is there's all these problems that are in the way of the practices, and I've got to get rid of them. I've got to eliminate them before people can adopt more sophisticated practices. So that was the birth of the maturity model. There's a set of problems in the way, and there's an order in which I've got to remove them so that we can really become a high maturity organization, have high quality, and be able to sustain that over the life of the development organization. So Watts came up with the process maturity framework with the 5-level model, but the difference was that it's not a practice-based model. That's what the quality maturity we had. It's an organizationally based model. So at each level, it's a different organization. And it's the organization more than anything else that's changing it. You change it by changing the practices, by improving the practices, by adding more sophisticated practices. But at each level, it's a different organization. It operates differently and it thinks differently. And that's the foundation of the process maturity framework. What makes it unique, and what gives it its power to have the impact that CMM and CMI have had over the decades. The real issue here, Watts never really understood what he had created. What this is the first truly original organization change and development model over the last 30 years. When Watts developed it, there was nothing like this out in the organizational change or organizational development literature, because they were all like, here's how you go about making a change. You communicate it, you have executives behind it, blah, blah, and then you do it. Watts didn't say that. Watts said that we're not going to make a big bang. We're going to do it in stages. Yes, executives have to communicate and lead, but we're going to do this in stages. It's organizational changes, but it's an evolutionary model. Come on, what's not working here? Why is this? There we go. Okay, so when we got Charlie and Watts together to work on, when we were building the CMM, we had to come up with what's level 4 and level 5. So Charlie and Watts kind of went off into an office and closed the door and sat there for 2 to 3 weeks and started thinking about what practices do we need at level 4 and level 5. Watts' book wasn't really practices. It was sort of, here's some things that people are doing. Here's good ideas. But now we had to codify that in practices. And when they got to thinking about it, there really wasn't anything out there at level 4 or 5 except the Space Shuttle Avionics project. So their guide was, what are the folks down in Clear Lake doing in the Space Shuttle Avionics project, because clearly what they're doing is working magnificently, and we ought to be adopting those practices at high maturity. They're doing measurement. They're not doing statistical process control. I'll show you what they were doing in a minute. But that was really the guide for what went on in CMM 1.1, and it was consistent with the things Watts had laid out in his book. And in his book, Watts had talked about statistical process control because he had seen this in a quality assurance book by Schulmeyer and McManus, and they talked about it. And so Watts thought, that might be a good way to try to really do a sophisticated job of controlling the process. So he created a control chart for some inspections that he had seen, and yeah, he had the variation, and there was some high and some low. But Watts knew because he knew what those inspections were, he was able to explain why some of the inspections were high because they had really talented, experienced teams and people on the inspection, why some of them were low. They were extremely complex algorithmic components, or they had inexperienced people on the inspection team, or what have you. So he was able to explain that, pardon me, the different data points and why they were either high or low on the control chart. Now, what does that tell you? It tells you that's not a control chart. You can't explain data on a control chart. The fundamental assumption of a control chart is the variation is random. If it's random, I can't explain it. If I can explain it, it's not random. It's not a control chart. It's a scatter plot, and scatter plots are extremely valuable. So most all of you know this. I'm going to run through this real fast. This was the different ways that high maturity was represented. This is level 4 in Watts's book, Managing the Software Process, then in CMM 1.1, and then in CMMI. The biggest change here was when you look at CMM 1.1, the split we made was between quantitative management of the process and quantitative management of quality. When they developed CMMI, they changed that split to be a split between things done at the project level and things done at the organizational level. A lot of the same content, but just a different way to represent it. And at level 5, pardon me, Watts had his split between defect prevention is really the big thing he talked about. There was a chapter I'll show you in a minute on process automation in the section of the book where he talked about level 5, but he had a lot of other chapters in that section that weren't about levels at all. So we're not sure whether he intended process automation to be at level 5, or that was just another chapter he added in because it was an important consideration that we ought to make when we're trying to mature a software engineering practice. But I want to talk about process automation because it's a critical issue, and there's a word for it. I'm not going to tell you what it is till later, but I bet before we get there, you've guessed it. And then we split in 1.1 between defect prevention. We kept that from Watts's work. The Space Shuttle had excellent work on that. And we kind of split technology change from process change. When CMMI came along, they changed defect prevention into causal analysis and resolution, essentially the same thing, although it could focus on more than just defects. And then they collapsed the technology and process change into organizational performance management, but that was still focused on continual improvement. So the other dominant quality model at the same time was a Toyota production system. And, it had just-in-time processes. It had Jidoka, which is build in quality early. Don't wait till you're in test. It had focuses on teamwork and training people on finding ways to reduce the waste. For instance, rework is a massive source of waste. And if you build quality in early, you cut up to 40% of your development effort, because that's usually what it takes to go back and do all the rework in a low maturity organization. But the entire production system was built on a foundation. And you see at the bottom, the foundation is standardized processes. That once we have standardized processes, we empower all these other things. Well, that's obviously level 3. And so once we have a level 3 foundation that has, proper training in place, has standardized processes that are adopted and trained, there's groups to support it, that we then have the foundation for some very powerful productivity and quality improvement activities. So that's what I want to talk about today, because frankly, I don't think that in the CMMI world, we've ever fully taken advantage of what the capabilities are of an organization that's already established a level 3 foundation. So let's start by looking at the concepts. I'm going to call level 4 optimized or optimized. I'll take the hit for, we listed level 5 as optimized. I think that's wrong, because optimize is what you do to the current process. It's what you do to the process that you have in place. I'm trying to optimize it. It's not coming up with a whole new process, right? That's innovation. So optimize is what we're doing at level 4, trying to constantly improve what we have in place. There's lots of techniques for doing that. We'll go through some of them. Then level 5 really is innovation. Our optimized process is not giving us the results we need. Either competitors are getting better than we are, or our customers are demanding more. And frankly, we just can't stay where we are with the optimization we've got and be able to compete. We've got to fundamentally do something different. We need to disrupt our process or disrupt our method or something. And so level 5 is really about delivering a whole new way of doing the work, whether it's a technology change, a process change, better training, or whatever. And there's a lot of methods for doing innovation, but the thing we have to remember is, if it's really done well, it's disruptive. And when you innovate, whether it's with the product or the process, it can be very uncomfortable, because people are going to have to fundamentally change the way things are done. I mean, remember when IBM came out with the IBM PC? Bye-bye IBM Selectric, one of the best-selling products they ever had, right? There were lots of products that were completely disrupted, but that was going to happen. We were going to go eventually to word processing, and so we didn't need typewriters so much anymore. And so that was a disruptive product change, and we need to be thinking about those kinds of things in a high maturity environment. I'll show some ways we can do that with existing products. So there's a number of practices that we can adopt at level 4, and some of them extend beyond what we're currently doing when we're trying to comply with CMMI. Rather than worry about process control, statistical project process management, I want to worry about predictive analytics. What's more important, frankly, is that I be able to predict the outcome at the end of the project from the work that's going on now, from the data coming off my process, so that I know if I need to take corrective action quickly. We'll talk more about that. There's a role for stable processes, but the way we get there is going to be challenging. Reuse, I'll talk more about that in a minute, but that has a huge impact on productivity. Self-managed teams are another powerful way to improve productivity. However, it's not what the agile methods folks think it is. They think that I just announced that we are an independent, self-managed, autonomous team, and we just go after it. The truth of the matter is, there's 40 years, actually now 50 years of research on what it takes to support self-managed teams. And there's a way you build up an organization so that you can empower people to be self-managed. And if you don't really have that foundation, the teams go off in all directions, and it's a mess. And we've had situations. I've had lots of executives complain to me about their agile teams are just running open loop and not really following the discipline of Scrum or whatever agile method they thought they were adopting, or they claimed to have adopted. In fact, when Jeff Sutherland, I attended a workshop Jeff Sutherland taught at one of the Agile conferences, at the Agile Alliance conference some years ago, and Jeff said that 70% of the organizations he visited were doing Scrumbutt. Not Scrum, but Scrumbutt. So we asked him, Jeff, what's Scrumbutt? He said, I'm doing Scrum, but we're not doing daily bills, but we're not doing daily meetings, stand-ups, but we're not, okay, you're not doing Scrum. right? That was the problem, that they claimed they were doing Scrum, but they weren't adopting the discipline of Scrum. So that's a critical issue. And that discipline is established in a true level 3 environment where we come up with common processes and methods that the organization adopts, that are under review by the quality process assurance group, et cetera, et cetera. I won't have much time to talk about supply chain integration, but look, once I've got a level 3 process, I can start expanding that and using that as a foundation for integrating the way I work with my supply chain, the way they work, and the interfaces we have with each other. So it offers a whole new capability for expanding out and really making my whole supply chain much more efficient, productive, and high quality work coming down the chain. I've had a lot of senior executives complain to me that they had a claimed level 5 supplier, and the code they were getting sometimes wouldn't load, was crashing. They had lots of problems with it. So part of that may have been problems in the supply chain and the way things were coordinated and what have you. So level 3 gives us a whole new way to work the supply chain. And finally, I really want to focus on the concept of a value chain. Value chain is from when I get it to when I deliver it and the customer is using it, right? So an end-to-end value chain is the way to think about a lot of the practices in high maturity, especially automation. And if I want to automate the value chain, there's a word for it. I suspect you know it. We'll get to it in a bit. Then at level 5, we already know we're focusing on innovating in the process and the technology, but also I'm going to talk later on about innovating in the product itself. And that ought to be a part of our thought process at high maturity, not just the process or the tools, but the product itself. And then there's organizational performance alignment. It's more than just continuous improvement. The fact is, some improvements interfere with other improvements. We see situations where we've sub-optimized some things because of other things. And the important issue here is that we evaluate the impacts and make sure that all the actions we're taking are aligned and that we've addressed whatever trade-offs we have to make so that the overall performance of the organization is moving in the right direction. And then at the end, I'm going to talk about agility. This is not agile methods. I want to talk about agility at the organizational level because there's some critical issues that have to be addressed in a high maturity organization. So let's go back to our old buddy, software process control and statistical process control. So here's a manufacturing plant. I've got 4 individuals. Each of them has the same tool they're using to do their individual work. And we take all their data and we plot it on a control chart, right? Isn't that how we do it? Take all the data from all the folks and plot it on one control chart. That's how they do it, right, in manufacturing? Absolutely not, because that throws in so many sources of variation that it just becomes junk, and it'll mask somebody whose machine is going out of control. So what do? They each person has their own control chart, and they're mapping their data onto their control chart to make sure their process is staying within the defined 3 Sigma limits, plus and minus, right? So they can see if their work is, or their machine is deviating from the thresholds it's supposed to achieve. So if that's the case, how come we're doing it that way in software engineering? Right? Most people, sort of the white rat of software engineering is inspections. It's the one we all use to go show our techniques and whatnot. And it's the one we always use to show that we've got a process under statistical control. And yet, all the different things that we throw on that plot are built by different people that are of different complexities. We had different people on different inspection teams, right? We've got assignable calls just running all over the place. And that's why Steve, kind of wish Steve were on the call. Steve called these quasi control charts. They're not real control charts. They violate the assumptions of control charts, but they're useful because they're scatter plots. Right? If we really wanted to do something that was more like what true statistical process control does, we would base something off Watts Humphrey's personal software process. And I would plot my data and I would learn about my data, but still it's not the same widget every time. Every component I work on is different. Uh, the conditions are different. All kinds of things are different. And so that's not random variation. I can explain that stuff. Therefore, the model of statistical process control is the wrong model. It doesn't mean we're not going to use statistics, but we need to use statistics that are relevant to the work that we're doing. So here's some data that was collected by Julie Bernard and Anita Carlton. Julie was at the Space Shuttle project at Clear Lake. Anita was at the SEI. This is data on inspections. They were looking at the amount of source lines that were being inspected per hour of preparation time for each individual. Right. So they plotted all that on this chart. Holy cow, look at some of those right here. 400, 350, 175, and yet most people down here around the 10 to 15 or 20 level down here, and yet we've got these folks. What the heck is going on? This process is completely out of control. I mean, we ought to be firing managers and things, right? Well, they went in because this is a scatter plot and asked the question, what is going on in these data? Well, lo and behold, they found that most of these large data points were inspections of data lists, tables, and arrays only. They were not complex. It was simple to review large amounts of material very rapidly because they were lists and tables and whatnot. Now, there's a couple down here at the bottom that look like they're almost at zero. So I suspected they didn't even review it. They just tossed it out. But the fact is, this was different than people reviewing algorithmic work. So let's pull those data points out of this control chart, because that's an assignable cause. It's completely different from what everybody else is doing. So now this is the control chart we get. This is the result. Well, holy cow, we've still got 6 data points that are way high compared to all the others. In fact, I've got a bunch of data points there in a string at the bottom that are below the median or the mean. Therefore, those are out of control. The ones at the top are out of control. Seems like the whole process is out of control. So the question they ask is, what the heck is going on with these ones that are high up? Lo and behold, those were components that were larger than 60 lines of code. And in those components, they found that the part that was critical to review, the hard part, was much smaller than 60 lines of code. So they could review that part very quickly. They could review the rest of the code very quickly. So they could review a lot of code quickly and then focus their time on the hard parts. And so that's why they were able to review it more quickly, because they had so much code that they could rip through very quickly. So let's pull those data points out. That's yet another assignable cause. And then we get a control chart that looks like this, much more typical of your standard control chart. Frankly, I've seen control charts where the difference between the upper and lower control limits was an order of magnitude. Now, no manager is going to look at that and think you're under control. They're going to ask you, what the heck were you thinking? That's crazy. Things that are 10 times something else, because there are so many assignable causes running through software data that you almost never see true random variation. And the proportion of these this random variation is extremely small compared to the assignable causes. The assignable causes are difference between people, differences between the complexity and difficulty of the components, the sizes of the components, all kinds of other factors. Maybe the time of day. If they're having to work at night, they're probably tired and they're making lots of mistakes. So there's just all kinds of assignable causes. If I look at a scatter plot and treat it as a scatter plot, it begs me to ask questions. And so what I'm suggesting is that, okay, you can do statistical process control if you have to, but the fact is, look at the scatter plot and ask questions, because you're going to find assignable causes, and that's the key to getting control. If I wanted to have control charts for this process I've just shown you, I have to have a minimum of 3, and it could be more. Well, for every process, the last thing I want is 6 control charts. So maybe what I really want to be doing is using my data to try to get control in a different way, to understand there may be different baselines for different levels of an assignable cause: experienced people, inexperienced people, large components, small components, data arrays versus highly algorithmic components. So those are the issues, and those are the things we'll find if we really start thinking in terms of looking at scatter plots and asking questions. So software data are filled with assignable causes. So random variation, which is the foundation of control charts, is really a very much smaller component. So let's look at what the space shuttle guys were doing, because they were doing something that looks like control charts, but it's not. What they were doing was confidence intervals. These aren't even 95% confidence intervals. They're experience-based confidence intervals. So as they started from 400 days out from delivery, heading down towards day 0 when they delivered the code to NASA, they had an expectation for the number of defects they would find in all their continuing defect removal activities, from inspections to unit tests to integration tests to system tests to what have you. And they would, as long as it fell within that confidence interval, they knew that when they were going to deliver the code to NASA, it was probably as close to defect free as they could get it. NASA might find one more defect in their acceptance testing, but this code was really clean, probably the cleanest code ever developed because of the rigor of the processes they use. Now you notice in this chart at day 210, look at that. All of a sudden they have a real jump in the number of errors they're finding. In fact, this goes up to the upper limit and stays there until roughly day probably 70. And then all of a sudden they don't find any more defects. So they were, what on earth is going on? Because they were really scared when they were in the upper limit there, that there's something wrong. This is really, there's some bad stuff in this code, and there's going to be a real problem when they try to get this stuff over to NASA. Well, all of a sudden at day 70, they stopped finding defects. They didn't find any more. At day 0, they delivered the code to NASA very gingerly and went back and did their post-mortem on what the process was. And lo and behold, they found that at day 210, in the inspections they were doing at that point, they had added a lot of new defects and problems into their inspection checklists. And lo and behold, it accelerated the rate at which they were finding defects. So that by the time they got to around day 70, they pretty much had found most everything that was in there. And in fact, what they now needed was confidence intervals that look more like an S-curve. So they had to go in and change the confidence limits based on after they ran this a few more times. And so if this really was their new defect detection rate, then that would give them a whole new set of confidence intervals. So here's something that was really important to them as they get to delivering the code to NASA. This is the data across all the releases, 22, 23 releases they had made. And you can see this is the defect reports for 1,000 lines of code during their test procedures, during all their test cases. And you know, they started up where most people are, 10 to 15, 10 to 14 defects per 1,000 lines of code. That was pretty common. That was back in the 70s. But by the time they were, got through the 80s, they were down to roughly 1 defect per 1,000 lines of code during test. That's all they were expected to find. And that was a consistent rate. In fact, later they got down to a half defect per 1,000 lines of code. So this is the objective. They wanted to get where the code going into test that was as essentially defect free as they could make it. So they were no longer testing the code. Really what they were doing is assuring that the code is as defect free as we can make it. This is really this is almost validation, not validation, but it's verification. They were verifying that the code was essentially defect free, and they didn't expect to find more than 1 defect per 1,000 lines of code, and they'd eliminate that. So that when NASA got the code, it was extremely high quality. In fact, most of the defects they were finding was in code they had written more than 10 years before. So that's what the space shuttle guys were doing. It's not statistical process control. It is very serious quantitative management. It's very serious, and it's not rigorously statistical. I mean, I'm not doing 95% confidence intervals, or they weren't, but it is still quantitatively based and statistically based. So here's what we can achieve if we start thinking about the value chain, and rather than worrying so much about statistical stability, we start worrying about predictive analytics, right? And so I've got all these different activities during my value chain that I engage in, from requirements through validation. I've got various quality assurance activities attached to each one. Those quality assurance activities produce data from the results of that activity. And I could take that data and enter it into, in this case, what looks like a regression equation that predicted the number of defects I would deliver to the customer at the end. Now, let's just say that's one of the critical measures we're trying to maximize and optimize when we deliver our product to the customer. And sometimes I'm looking at this equation and all I've done is requirements inspections and design inspections. And so I'll only have basically two parts of that data. And so it won't be as predictive, but it'll still give me a general idea. Am I on track? And if not, what's wrong? Were there a lot of bad requirements? Were we missing lots of requirements? Did we make some serious mistakes in design that people were coming up with? I mean, this tells me I need to slow down a bit and start making some corrections now, so that I don't buy the farm when I'm getting out into tests, so that my tests will be reasonably clean, and they'll be verifying the correctness of the code rather than finding defects. So as we go down the chain, as we go down the life cycle, we're adding more and more data that gets us more and more prediction. And let's say the reason I want to be able to predict delivered defects is because, based on this customer's product, they really want to know the availability of what they're getting. Is this thing going to crash frequently, or is it going to be steadily available? If I'm running a critical retail website, or if this is a pacemaker, availability is absolutely critical. And if my delivered defects, if I get enough operational data to show that delivered defects correlate with the availability, then I've got a nice set of equations that predict things that are critically important to the customer. So this is how I want you to expand your thinking. Are statistically stable processes helpful? Absolutely. The more stable the process, the fewer the defects, but it doesn't mean it's statistically stable, because there's going to be assignable causes. But if I understand those assignable causes, I know what to expect, I know what to look for, and I know what remediation activities I have to take early to make sure those assignable causes don't create problems at later stages in the process. So when I do get down to delivery, I'm able to predict that this thing is at the level of defect tolerance the customer will accept, and that it will achieve their availability goals. So that's the way I really want us to move up and start thinking about quantitative management and about what we do with data and statistics in a high maturity environment. We saw a miracle at level 4 back in the early 90s, and it kind of shocked us because none of us had really thought about it. But I bought a book at a bookstore. It was on process improvement, software process improvement, and one of the chapters was by a bunch of folks at Omron company over in Japan, and this is the data they were showing. As they got to level 3 there in 91, and they were using Watts's book and the questionnaire and anything we had produced at the SEI to kind of say, yeah, we're roughly at level 3. And as they got there and had a standardized process, their reuse exploded. I mean, the reuse dramatically increased. Their steps per million yen. A step is roughly the equivalent of a line or a function. It's how they measure the amount of stuff they're producing, the volume of product they're producing. And so lo and behold, this went on a whole new path, and the productivity exploded because they had a standard process. And was this just Omron and maybe there's some magic in the water over there? No, actually, at about the same time, John Vu from Boeing came to a conference at the SEI and produced essentially the same data. This is data from Boeing Computer Services, and it all of a sudden he saw projects producing lots of reuse, that they were using things that, and this is before open source. I mean, open source makes reuse very easy these days, but this was back when you really were reusing things you'd built in the past. And so what was going on? Why did level 3, because we've been talking about reuse for 20 to 30 years at this point, why did reuse suddenly started exploding with people that had gotten past level 3? It's because finally at level 3, you trust the stuff you build. You didn't trust the stuff you built at level 1. You knew it wasn't documented. It's probably not under decent configuration control. You can't find the source code. Yeah, it's just it wasn't tested properly. People were in a rush. They slammed it out, didn't design it well, and frankly, it's going to take more time to modify it than it would be just to build it new. So you just go rebuild it. But once you get to level 3, you know it's been developed with a rigorous process, properly tested, reasonably well designed. You can find it. There's sufficient documentation. And so frankly, it becomes easier to reuse it than to try to modify it or start from scratch or modify something that was old. It's easier to reuse well-developed code than to go ahead and build things from scratch. And that's why the reuse took off. And so that is not a part of the current models. It is a part of the business process maturity model, and it's part of the people's CMM because we built those after we started seeing this data. But the fact is, it's something that every high maturity organization ought to be thinking about, whether it's in the model or not, because it has such a dramatic impact on your productivity and frankly on your quality, because you're reusing thoroughly tested components. You're basically pulling quality forward into future products. So let's go think about the product itself here. There's a number of software quality characteristics. Here's some important ones: changeability, reliability, performance, efficiency, and security. And there's all these things the business wants, things that represent value to them. But if you walk into an office, an executive's office, especially a business executive, and you start talking about quality, what happens? Well, the first thing you notice is their eyes roll up into their head, and then ultimately they fall asleep. They've heard this stuff before. They're tired of it. It wasn't in the past. It hadn't been delivered. So what you've got to be able to do is tie software quality attributes to business value. And so the question we ask is, what are the tactical objectives we want to achieve by having reliable software? And how does that play into things about maximizing business agility or optimizing work productivity for people who aren't in IT? And all these other issues. So if we can walk through the chain, then we can help business people understand why some of these issues are critical. Security they get, but they don't get changeability. And I'll show you why and what we need to do about it. Basically, we're talking about cost and risk. Though these attributes that are in the ISO software quality model really talk about the cost and risk of software to the business. And so let's say the business wants to maximize its agility. They're in a highly competitive market. They've got to be making constant updates to the website to match things that our competitors are coming up with to improve the experience of their customers. And so there are some quality characteristics that are very relevant to that. And I want to be able to explain to the business how these are going to create agility. The bottom line is software quality is a direct limit to the agility of the corporation, at least as they do business through a website, or to their process if their process is automated. Because the harder it is to change a piece of software, the longer it takes, and the longer it takes, the less agile you are. And if they see that, if we can explain it to them and reduce learning curves and other activities, then they can get why it's okay to spend money on quality, because ultimately we can translate that into some business value, in this case, business agility. Business agility and agile methods are not the same thing. If you go into a bank, what's the first thing you notice? How do they grow? They grow by acquiring other banks, all of whom had their own process and want to keep doing it the old way. And so I've got a zillion different processes. And when they go to IT, the requirement statement is a mess. I've got to support all these different ways of doing the same thing. We went into a big bank and found that in their credit card division, they had 183 processes, 18 of which were ways to open a credit card account. So that was just a nightmare for IT to try to automate. So we worked with them for a couple of months, cut it down to 50 basic processes and 3 ways to open a credit card account. If we'd worked with them longer, we could have cut it beyond that because we still saw redundancy. But the fact is, if I'm only working with one business representative, and that's typically what happens in agile methods, I've got my business rep, right? That person comes from one of the businesses or one of the locations, and the other locations may be doing it quite different. So I'm getting input and reacting to one person from one location with one process, when in fact people want a lot of different things. If we want true business agility, what we've got to do is get the business to standardize their process, to rationalize their process, and then we start automating it. But if I'm automating what the way most businesses operate, with a bunch of different ways to do the same thing, it's going to be a disaster. I'll create code that's hard to change. It's going to be very expensive and whatnot. So frankly, modernization begins with modernizing the business process, and then we can carry it into IT. But I want to be able to explain how these critical business software attributes translate into some critical piece of business value. Now, if once they understand that and say, yeah, go ahead and really spend some effort on improving the quality of your components of your system, then how am I going to do that? Well, the fact is we've got to adopt various forms of static analysis and different forms of dynamic analysis, because most of the problems in these areas, the problems that crash systems, that open holes for hackers to get into, are structural weaknesses that are not easily detected with your standard test cases. Test cases typically are functional to really get after the structural weaknesses in the software that degrade system performance and crash systems and whatnot. We really have to look at the actual structure of the code and analyze that. There's a standard for that now. ISO 5055 was released last year. It was developed by the consortium I run, that's a part of the OMG, the Object Management Group, and it contains critical weaknesses, not every weakness, critical weaknesses from which you can measure the security, the reliability, the maintainability, and the performance efficiency of a system. So those are 4 of the 8 software quality characteristics that ISO has in their model. So that's useful for guiding what you want to analyze when you're doing static analysis on source code to find the critical weaknesses that can cause these problems. So that's something we ought to be worried about in a high maturity environment, is really analyzing the code to see what is it we need to do. Just because I've got my test cases under some level of statistical control doesn't guarantee I'm not going to have serious problems. I need to start collecting, analyzing, and doing statistics on the data that would come from static and dynamic analysis. That's going to tell me an awful lot about how my system will operate in real environments. Product innovation through product analysis. Let's go back to Six Sigma, because that was real popular in the 90s. GE adopted it in a very broad way. A lot of the companies were doing it. And a lot of the black belts I talked to said they learned the capability maturity model, the process maturity framework, by accident. Now, how did that happen? Well, in Six Sigma, if you remember, to justify a process improvement, it has to achieve a certain level of business benefit. You've got to have an ROI that's sufficient to justify the project. Well, a lot of the black belts were running into the fact that they couldn't get the benefit up for a project they knew was important. Why? Because it really only addressed problems in one or two units, because other units were doing the same thing a different way, and it wouldn't affect they were doing their work. And so I said, I finally realized I've got to get standard processes in place so I can run Six Sigma projects, so I can get enough impact to justify the project. So that was one issue. Now, eventually, they ran out of opportunities to generate enough ROI to run the next process improvement project, right? So were they out of business? Well, no, they got to thinking about it. And some of the folks created Design for Six Sigma, which is once I've really optimized the process, the next opportunity for significant growth in productivity and quality is in redesigning the product, because there's probably lots of opportunities in the way that thing has been built for streamlining the way it's built in the future, for streamlining the way we can analyze it, test it, do all kinds of things, so that it'll be less likely to have severe weaknesses and defects. So Design for Six Sigma would tell us that we ought to, in a high maturity environment, ought to constantly be looking at the product itself and how we can redesign it. Now, today, what are we calling that? Modernization. People are going in and say, we could make this product, this software system, much more efficient if we could get it into the cloud and we could break it into microservices and this, that, and the other. Well, a lot of organizations start modernization and then basically break down. They some of them just flat stop it, because they run into situations where it's too hard to take truly crummy code that's so complex and so highly coupled that it's hard to break it into microservices. It's hard to get ready for it to run efficiently in a cloud environment. And so they're really struggling. And the issue then becomes, I really need to analyze the code and get it into shape so that I can make the improvements I need to make, the redesigns I need to inject into it, so that I can move it into a more productive, cost-effective environment and reduce my operational costs. So this needs to be, again, a part of a high maturity organization. They're not focused just on the process. They're also focused on the product. Remember, quality is focused on the product, and that's a big part of what we're trying to do in a high maturity organization. This takes quality to a whole different level. It says let's at a high level, let's rethink the product. There's a level 4 and a level 5 piece to this. At level 4, I'm thinking about removing the technical debt. There's a lot of technical debt out there. It makes it hard to modify products. It makes the business less agile. And so at level 4, I want to go in and try to remove some of the technical debt to clean up the existing product. Level 5 innovation, I want to go in and start thinking about, how do I redesign this so I can change the way I operate the product, break it into microservices and other kinds of advances that would really be fundamental disruptive changes in the way my product works. And in some cases, that'll create changes in the way the business works and make it more efficient. So that's one thought that we need to have in a high maturity environment. So what does this mean? It means identifying things like architectural hotspots where, lo and behold, there's lots of system-wide problems that run through that component. We better don't go in and do a lot of corrective maintenance on it. Throw it out, burn it, because it probably has had so many people working on it. It's a complete kludge. It's hard for people to understand where they're trying to work with it to make a new enhancement, and it's better just to rewrite it, start it out and clean it up, rather than trying to modify a piece of junk. And change prone clusters the same way. So and frankly, you're probably starting to find in some parts of an application, there's some stuff that's really becoming old and you want to modernize it. So identifying where the legacy code is would be useful. And frankly, identifying where the dead code is can be critical. we've actually analyzed code, some applications, and found that 40% of the code was dead. It wasn't reachable. Now think about that in a cloud environment and what it's going to cost you. And then if that code ever gets reactivated, it's likely to cause problems. Night Trading had some dead code reactivated, and it made $440 million worth of bad trades in a half hour, and they were bankrupt. So getting dead code out of the system so that some enhancement, some update doesn't suddenly spark back into it is fairly critical. And there's all kinds of techniques. There's architectural analysis. You can see a visual representation of the architecture. You can go in and with a good tool, you can ask all kinds of questions about different components. You can see what's hooked to what. Graph-based clustering, support vector machines. That's an artificial intelligence approach to go in and analyze various aspects of what's going on in the system. I showed you some regression methods. There's just all kinds of ways. Some are machine learning, some are basic multivariate statistics, some are advanced software analysis techniques. So, but this would be expanding what we think about as high maturity. It would really be an issue of understanding what's really in the product, what we need to change, get the dead code out, and ultimately innovate with the way it's created and designed. So automation. This is an image of the 18th chapter of Watts's book, automating the software process. Watts knew this was critical. It was lost as we moved into CMMI and CMM, but Watts just knew that there's something here. It's something we've got to think about. The productivity improvement is way too great, and in fact, the quality improvement could be massive if it was done well. So we weren't exactly sure exactly how to include this, so it never really made it into the models. But think about what most people have. They've just got a big clump. In fact, lots of clumps of tools. Every project's got its own collection of tools. You've probably got Federal Configuration Management System and several different testing tools. And the only tool that everybody's got in common is Jenkins, because everybody loves the image of the butler. So, but the bottom line is this: for IT, this is a nightmare. They're trying to manage all these tools and the licenses and who has access and the support and the updates, and it's just an absolute nightmare. So the bottom line is when I get to level 3, at level 2, this is going to be typical because the projects are still running independent. They've got their own process. It's repeatable. They're trying to find out what would be more standard, but this is not atypical at level 2. But at level 3, when I standardize my process for the first time, I can start standardizing the tools that I use in the process. It enables us to create a DevOps tool chain, right? A lot of folks are trying to move to DevOps. Many of them are struggling. The vision of a DevOps tool chain is all these tools are integrated in a pipeline and data just flows down them like water down a river. That's not the way it works. Data, it's hard to integrate the data and the product data across all these different tools. The interfaces may be different. I mean, there's all kinds of issues, but people gradually in an evolutionary fashion get more and more of this integrated. But this is a powerful way to optimize a level 4 environment. If you have a standard process, we get everybody adopting it. The worst thing for me is I've adopted the standard process and I suddenly get assigned to another project and they're using a whole different set of tools. And it's just a nightmare. I got to spend a lot of time learning the tools and not doing real work. So once we can get to a pipeline, maybe it's a DevOps pipeline or whatever, once I get to that, at least I understand the tools I'll be using if I move to a different project. And the more integrated we can get them, the data, the way things are traded between tools, the better. So, and a lot of people have given up and only left it at a partial pipeline because they just found it too hard. So part of this is waiting until you get a standard process, and then using that process is a way to identify what you want, what tools you want, and how you want the data to be represented so that it moves through as many tools as possible. So let me kind of summarize a reconceptualization of the process maturity framework. Level 1, we all know, well, I don't agree that level one is performed. I mean, I know that that's the way it is in CMMI, but until you establish a level two capability, level one is not stable. Why? Because level two, I get control of managers. I get managers to start building plans and incorporating the staff and building those plans. And if in a level one environment, without those controls in place, a manager can walk in and give you an idiotic schedule that throws you into a death march project, everything goes out the window. You're no longer stable. You're not performing the practices. You're performing the minimum amount just to get through so you can slam out the code on a nutty schedule. So I really worry about thinking that level one is performed. A project may be stable if they've got a manager who's already adopted the level two practices. The organization may not be there, but at least the manager and that project is. So I might give performed to a project when I see that they are already really functioning as a level two project, but the organization may not be there because other managers are just doing whatever they do. So the bottom line is level two is stabilized. I've stabilized local work units, local projects, local work. And I've got to the point where the work is repeatable. Once it's stable, I can repeat the practices that I know work. Level three is standardized. The fact is now I can go into all these repeatable practices and look at what's worked best and standardize that into a standard process. And frankly, it's only when I get to a standard process I can scale a business. If everybody's doing it a different way, even if it's repeatable, I can't scale it because it's basically a tribal culture. It's people doing what they do. Once we have a standard process, sure, we'll have tailoring guidelines. That's fine. But we have a process that we can scale across additional projects, additional business units, additional parts of the organization. Then at level four, I'm optimizing that process. And the goal is I want it to be predictable. I want to be able to predict that I'm on track to deliver the outcome that we've committed to deliver, whether it's internally to the company or to an external customer. So the goal there is to optimize my processes to where I'm optimizing their performance, their cost profiles and quality so that I can get a consistently predictable outcome and I can track that all the way through the project. So if all of a sudden I predict I'm not on track, I can take corrective action early. That's what a true high maturity organization does. And then level five is innovative. And in fact, in many cases, I'll be disrupting my existing project, my existing process or my existing product, or even better, the marketplace. So level five, if we're constantly innovating, we're becoming a relentless competitor who has the ability to disrupt things. So to summarize my summary of the process maturity framework of true maturity models is stabilize, standardize, optimize, innovate. That summarizes it. Executives get that. So we're developing a meta model. Over the last year and a half, I've worked with a couple of organizations to build maturity models that were outside the domain of projects and software and systems and all that. One was in healthcare, where they were trying to help hospitals and clinics adopt automated clinical pathways. And so we built a maturity model that is reasonably faithful to the process maturity framework, at least up through level four. And they're now using it. It's actually going into use. Most of those yams were never really used. But if we have a really good, well-formed maturity model, people will see the value and they'll start using it if it's not too bureaucratic or too burdensome, if it's not bloated with too many excessive practices. I mean, Watts's notion and the notion Charlie and Mark and others had when we built the original model was just include the practices that are critical to creating the capability at that level. And if people want to do some other practices, that's fine. But the model will have the ones we know to be critical to establishing that level's capability. So let me give you my mantra to end it. And Curtis's mantra is that winners have better people. If I've got better people than you do, I'm going to beat you 99 times out of 100. I mean, maybe it's raining and it changes things. But most of the time, if I've got better people, I'm going to beat you. I'm going to win. However, when we get down to the championship round and the few really good ones, we've all got good people. That's why we're there, right? And in the chaos of the final few minutes in a championship game, the team that wins is the one that has better organized people. The integrity of the coordination among the people on that team is sustained even under conditions they've never seen before. When the other team is throwing all kinds of weird things at them, they still can maintain and adopt and adapt to what's going on the field. And so champions have better organized people. Now you notice that champions win it this year, but not next year, not the year after. But occasionally in some sports, there's a team that just seems to win it and win it and win it year after year, decade after decade. They're in the championship run and win more championships than you'd expect them to. And you call them dynasties. And the fundamental issue with dynasties is they have better organizations. It's not about the individuals. They're going to change constantly, right? It's about instantiating that process, the training, the way people work, the culture so deeply that the organization carries the culture. CEOs change, but the truly great organizations stay great because of what the organization has developed. That was the foundation of Jim Collins's book, Built to Last. That the companies that were really outstanding, that were better than companies that were just good, were the ones that really had built better organizations, and the organizations sustained the greatness. And the same thing in his subsequent books, Good to Great and some of the others, is that it is the infrastructure you build and sustain over time in the organization that creates a true high maturity environment that can sustain itself. And frankly, we've noticed that when organizations that were high maturity, a new leader comes in and says, we don't need to be doing all this stuff, and starts peeling it back, people leave, and they leave in droves. Space shuttle folks said flat out, if they ever wanted us to stop doing it this way, we would all resign en masse, because we would never put the astronauts at risk from second-rate code. This is the way we do it. We know the result. And those guys live in our neighborhoods. We don't want to lose our neighbors. So that's that. We've seen people. I've seen people at other organizations that just fell back to level 3, and folks left. So being able to sustain this over time through different organizations. Actually, the space shuttle project got bought by 4 different organizations over a period of 4 years, with the final owner being Lockheed Martin. And when the CEO went down there, he said, this is the one thing I've got that's working. Don't anybody mess with this. So that's the bottom line. Winners have better people. Champions have better organized people. Dynasties have better organizations. And that really is the kind of progression that we hope to see in a maturity model environment, when people are serious about adopting this, not for compliance, but for results, for becoming a relentless competitor. So let me throw it open for questions and answers. We got a half an hour left. And by the way, I'll provide a copy of the slides, a PDF of the slides.
Yeah, there'll be a copy of the slides up on the website.
Did I talk so fast that nobody can formulate a question? Pat O'Toole has to have a question.
Okay. As you know, CMMI version 3.0 is coming out in first quarter of next year. And one of the major architectural changes in CMMI version 3.0 is to achieve maturity level 2. No longer are they focused on 7 or 8 practice areas, the ones that Watts deemed critical, but they're now making it mandatory to do all the level 1 and level 2 practices in all 18 or 20 or whatever number of practice areas you're including within the scope of your appraisal. Thoughts on that?
Violates one of the fundamental principles of designing maturity model, which you just stated, is you only want to include at each level the practice areas that are critical to that level. Otherwise, you make it a bureaucratic mess. It gets bloated. people get tired of it. I've seen an organization that try to get to level 2, and they were working with the lead appraiser I have great respect for, and they didn't make it. And in the process of doing it, they had to create all this bureaucracy, and it was in the way. And they finally said, "The hell with it, we're dumping CMMI." And that was unfortunate, because they were a smart group. They had a good process improvement group. They could have made a lot of benefit, but it just got too. And that was the problem with the generic practices. I would, from the time they created CMMI, I was against the generic practices. It was the reason behind them was thought that the continuous model and staged model were two representations of the same underlying process improvement model. And that was completely wrong. It was false. They are completely different models. They focus on different things, and you shouldn't try to make them the same. The continuous model focuses on individual practices, more like Crosby's quality maturity grid, and raising each practice up some number of levels. Whereas the staged models are focused on the organization. The unit of change is the organization, not the practice. My goal is to use some processes to move the organization to the next level of its capability as an organizational change and improvement activity. And so when those got mixed up, it really gummed up the model, led to a lot of bloat with all those generic practices. I congratulate CMMI version 2 for getting rid of the generic practices, because it wasn't going to be hard to get those into some kind of form where they could be there for institutionalizing improvements, but not bloat the dickens out of each practice. I mean, there were process areas with 3 practices for which you had to apply 10 generic. That's insane. Bottom line is, I think version 2.0 was a massive jump ahead in the structure of CMMI. But I think this goes back to a bit, sounds to me like, we'll see, that it goes back to adding some bloat in that doesn't really help you get to level 2. And I don't know, why would I want to spend time putting all the management practices in and configuration practices in for optimizing and innovating when I'm a long way away from doing that? I mean, I'm just telling the manager, "Oh, by the way, buddy, here's all this other stuff. You're not going to do it for a couple of years, but you're going to have to adopt these practices now." As a manager, I would just raise the dickens about that. It's in my way. It's in my way of focusing on what's important for the project and the customer.
I have a question. This is Dick.
Yeah, Dick.
How much of the agile methodology and practices, the 12 of them or whatever there are, hurt
Yeah, if you're
engineering and process
yeah,
improvement?
I think what hurts is the fact that so many agilistas don't do it. Right? They don't follow the method the way it was written. They don't do, daily stand-ups, daily bills, daily whatever. And another thing that hurt, the second year I went to the Agile Alliance conference, I was hearing this all over the presentations and out in the hall, and it was constant. And I still hear it when I talk to folks. One of the principles of virtually all the agile methods is that when I have locked down a sprint, or whatever it's going to be called, the short-term iteration, when I've locked it down, when I've accepted the number of stories that we've agreed to perform, that is supposed to be sacrosanct. You can't add more. Now, you can add them into the next sprint, because that'll only be a month away or 2 weeks away or whatever. But the fact is, I was hearing over and over again, yeah, these dang marketing people or the business guys come in and they demand that all this stuff be added in. And, somebody caves in and comes down and tells us, well, you got to do this too. And of course, that blows a sprint. We're back into level 1 right now. Now I'm not going to have time to test properly, and I'm going to be back in the same mess. So there's got to be somebody on the team that has the wherewithal and the authority to stand up and say no. the fundamental word that managers or team leaders or whatever have to learn at level 2 is the word no. Right now, if you want us to add that in, then we're going to have to reanalyze the project. We may have to add time to the schedule, or we may have to cut some other functions out, right? But we can't get unbalanced. We've got to keep a balance between the resources and the commitments, and that's not happening in a lot of agile projects. They people come in and keep adding stuff, they get overloaded, so all hell breaks loose. I think that's the worst thing that happens. But if they're not following the methods rigorously, I mean, agile can be a level 3 method if you really do it right. Now, validation may be hard. I don't know how in some of these cases you validate, which is a level 3 process area. If you're just on a constant series of 2-week iterations, they're not going to have time to get the system out. In fact, it may not be ready to take out and validate in the customer environment. So, you could call validation, well, my customer rep liked it. Okay, it's not really validation, but what are you going to do? So I think I've seen a lot of reinterpretation of CMMI practices to try to fit what is an agile environment. Right, level 4, I've actually seen an agile organization doing level 4 like statistical analysis of their data, of their defect data, and looking at the defect rates they were seeing. They had plots up on the wall, they were tracking it, they were making sure that the sprints weren't delivering junk. So I've seen that done. So I know that there's at least some of what's at level 4 that can be done by a really rigorous agile team. And I know ThoughtWorks at one point was building a maturity model. Actually, they had me up one time to help them think through how they should go about building it, because they realize there is value in taking a mature approach to an agile environment, as opposed to just letting people get away with willy-nilly hacking. So it can be done, but people have to think it through and really, really be willing to adopt it. It may, some things may have to be done on every second sprint or third sprint or whatever, because that's what it makes sense for that practice. But it can be done as long as they're rigorous and disciplined in the way they go about it. And they may add some practices in. I mean, a lot of folks with big systems are using SAFe, the Scaled Agile Framework. Well, that's not classic Agile. They added in a lot of stuff that would be required for executing a large project to make sure it's on track to hit its targets. So,
here's a
you know,
question
that-
in the chat from Sam Gao. My question is, if automation is so important, shall we add a process automation practice in the model? What
I
are the
think so.
pros and cons?
I think so. I mean, you want to word it so it doesn't require things that most people can't achieve, and that's going to be tough. But I do think it would benefit, because we see that happening in the better organizations, right? The better ones are going to DevOps and are trying to get it integrated as best they can. It's not easy. There's an article I published with Barry Schneider from Fannie Mae and IEEE Software 3 or 4 years ago that showed how they use data to guide their implementation of a DevOps environment and agile methods. And they were constantly looking at the productivity and quality data to see what tools were working best, which ones weren't delivering, and what they ought to include in their standard pipeline. So it's possible to do it. It's an evolutionary process. It's best done with data on what results you're getting as you bring new tools in. But I do think it would be powerful to add both product analysis and automation into the model, because that's what real high maturity organizations are doing. And with product analysis, you've got reuse and a lot of different modernization, a lot of different things. You'd want to word it so it doesn't require too much, so it gives them the flexibility to do sensible things for their environment. But the really good organizations are doing that. The really great mature organizations are doing it. And the ones that are trying to do it that aren't succeeding, you look at what they're doing, they're not that mature. They don't have a standard process, or they don't have good control over their commitments, and they don't
I
have good
guess I
training.
raised,
Go ahead.
I raised my hand. I have, thank you very much, Bill. It's a very insightful presentation. I have two quick questions. And one, I noticed the process performance model was not in the original CMM model. In the high maturity practice, we didn't have a process performance model. So what is your view in terms of the value and the role the process performance model should play? That's the first question. Second question, innovation. Can you elaborate a little bit more? What are the more proven approach to better manage innovation?
Okay. Let me just throw something out for that last one first. Don't expect your project managers to innovate. And some of the optimization is not going to come from the project managers. They're busy running a project. Innovation is best done if you have a group that is constantly surveying the horizon to see what's out there that's better than what we're doing, what tools are coming about. You know, if you got a research group in the organization that can build tools, maybe look at some of the problems you've got and task them to go try to come up with an idea and a tool or a process that would solve it. So really a part of what you've got to do at the highest level is have a group that's focused constantly on looking what's better out there that we could adopt. What are the universities doing? Nothing wrong with having a research collaboration with the university if they're in your area. Process performance. Yeah, there in the CMM, and this was a limitation, and boy, do we have some arguments over it. In the original CMM 1.1, it was just limited to the software part of a large project. We realized early on, Mark Paulk and Jeff Perdue and Tim Cassie and me and a bunch of others, that 90% of the projects that people had assessed were having requirements problems, and there was not a requirements process area in the model. So we proposed that we put one in, and so Charlie and some others built a really nice requirements analysis and management process, and we took it into review and it got slaughtered. And the notion was you don't want anything more than requirements management, because you're starting to get outside the process that the software group has under control or could have under control, right? So it was from the time I get the requirements to the time I deliver the code. And that was a real limitation. And so there wasn't a thinking in there about, by the way, does this achieve the business's objectives? Does it hit their thresholds and whatnot? Because that was outside of where we were, because most of this thinking was being done in a large system environment. So that was thinking that was added in CMMI. I think, Pat, check me on this. I don't think that was as strong in the early versions of CMMI.
Well, requirements management was in CMM version 1.1 on, and it was in CMMI version 1.1 as well.
Yeah. Well, requirements management was only managing the requirements once you got them. There was no requirements analysis.
Right.
And we fought hard over that. I'll tell you who, Watts was saying, I only want you, and Watts had stepped back from managing it, but he made strong arguments that 1.1 should only be from when you get the requirements to when you deliver the code, period. That's it. It's all we can control. And so, okay, so requirements management was just literally managing the requirements we've received, right? Validating that they're reasonably okay. But that, that CMMI went beyond that. We had requirements analysis, but that was at level 3, et cetera, et cetera. But I'm thinking about the addition of business performance when we worry about whether our project is delivering business results or not. I think that was much later in the life of CMMI.
Hmm.
And the reason I would think that is because CMMI version 1 was a total piece of garbage, because they really were so far away from the CMM. Watts had gone and offered to help. They told him he wouldn't be needed. They didn't want me involved. They made Mark Paulk so mad he wouldn't be involved. So they just produced a mess. So they got Charlie and Mike Conrad involved in the project, and that's basically saved it because those two guys knew what they were doing. And they got to version 1.1. It was a decent model, but it was primarily developed by guys in large weapon systems, right? It was DoD that took over the process program at SEI and made it what they wanted. And they said, that's it. This is what we want, because we raised issues about, banks and other businesses wanting to have input into this. And they said, sorry, this is a DoD thing, and we'll build what we want and what we need. So for instance, you never found the term shared resources. You never found the term portfolio, which are huge resources in an IT shop. So this was built for single large programs. CMMI was not, especially at level 3, was not designed for businesses that deliver products to the marketplace or for IT shops or whatnot. And so they used it, they interpreted it, they made benefit with it, right? But so the business aspects of it came in later when people realized we really need to tie this to the value that the business gets from the software and the systems that we deliver. And that was not in the early versions, but it's now in the later versions. And that leads us to really this thinking about the value chain and analyzing data across the value chain so I can predict that I'm on track to achieve that business result. And I think there needs to be more richness to what's in CMMI to help people think through how do we go about across the value chain doing things that predict and manage the result all through the process to get the business result. Just having a stable process is not adequate for that. In fact, I heard one lead appraiser who I have respect for say that as long as one process is under statistical control, it qualifies for level 4. Wow. That's just one process can be under control and others can be out of control, and especially if they're near the end, or near the beginning. The problem with the continuous model and thinking based on that is that any value chain is a collection of integrated processes. And I can't just improve one, because if there's a problem between them, if there's a break between them, then I'm not going to be able to deliver the final result. Think of Goldratt's theory of
Constraints.
constraints. Yeah, I'm blocking on the word. Think of his theory of constraints. The weakest link determines the outcome. And that's why the continuous model is not a strong model, because it doesn't deal with the interactions between the processes and the removal of weakest links. Right? I need to treat the entire value chain as a value chain and manage it as a value chain, quantify it as a value chain, so that I know all along the way I'm on track to deliver what the customer wanted. And I can predict that, and I can take corrective action early when I see my predictions are not suggesting my best interest.
Mhm.
So there's another question here. Let me see if I can find it here.
I may not have answered all the questions that were asked. Sorry if I didn't.
There was one person more that oh, Antonio, you still have a question?
Yes, I have. Bill, my question is to explore the last 20 years. We know that look at the past, we have a high penetration of the CMI in US, in India, and in China. We have a lot of organizations adopted CMI in these regions, but we never achieved success in Europe. We never had a huge adoption in Europe. My question is, first, why? Second, what can we do now to improve this adoption rate in Europe?
Okay, yeah, great question. I mean, Ericsson was an early adopter of CMM and went way up the value chain. Pat was involved with me in the work there. They were dead serious and they were looking at business outcomes. And it spread somewhat there. But here's I think what happened. I'll tell China, my gut feels that China is using it because they want to catch up with India. India is using it because it's required in contracts, right? The US, and I can tell you, I know for a fact, because I've heard from some of the companies, is not using it unless it's required by a contract, and DoD stopped using it in contracts. And once they stopped, everybody else starts dropping it because they weren't getting the results they wanted. It was too bureaucratic, too cumbersome, and caused people to focus more on compliance than on results, on end results. And when they really started not using it was around the time that they were building that new jet fighter, the F-35. And when they dropped it and didn't use it on the F-35, I'm terrified. I never have been so damn scared in my life because my house is 10 miles off the end of the runway where they're testing the damn thing. Right? Oh, damn, we lost some ordnance. Sorry, Curtis. Bye-bye. So, the bottom line is DoD largely has dropped it because they felt it was a bit bloated, even though they were responsible for building the early versions of CMMI. It was overloaded and people were focused on compliance and I think the same thing happened in Europe. They're not, if you're an outsourcer and it's in your contract, you got to do it. And I've had some outsourcers tell me we will not do it on projects which do not have contracts that require it. We'll only do it where it's required. Now, with the randomization of selection of projects, maybe they make areas where they only have projects that are under contractual requirements. But the bottom line is, I know I've heard from some that we just do it where it's required. Europe, what's in Europe, the customers. Well, the customers aren't using it because it's not required, because they felt it was burdensome. That company I said was trying to get to level 2 and dropped it was a European company, a very large, well-known European company, very well respected. And they just decided, I'm creating more bureaucracy to try to comply with what's expected of me at level 2. And it's in the way, it's not helping me. So the fact is that, and that was when we had tons of generic practices. I think version 2, if it's properly positioned, if it's properly argued, could help get more adoption in places that have, for the last 20 years, fallen away from it. However, as Pat says, this new version 3 could in fact impact and keep people away. So just because of that added bureaucracy at level 2. So I don't know. I think if we think about lean principles, I showed you the Toyota production models. That's the foundation of lean. I was concerned that CMMI was not lean and in fact contradicted lean, because when people did the appraisals, you essentially had to comply with every practice. That's not lean. If a practice doesn't add value, why am I doing it? Especially some of the generic practices, right? So what we need to do is think lean. What benefits this product or this service or this software system? What's the benefit that helps us do it at less cost, produces less defects so we have less rework, and generates more benefit for the customer? And once we get that thinking in place, we'll build models that are really focused on benefit to both the developer and the ultimate customer. But I think that's going to have to be the mindset. Just saying we're worried about the performance outcome of the customer is not the same as saying I have crafted a model that is, kind of lean and focused on that. Here's the problem I see with an awful lot of maturity models. They are academic. And I get scared that CMMI becomes that. What do I mean by academic? I mean, it's designed by a matrix. I've got a bunch of practices, I got a bunch of levels, and I got to fill every box. Okay, what would you say about a system designer that had a bunch of functions and a bunch of attributes they would add to those functions and decided to fill in every box? You'd say they were just dumber than dirt and they're a lousy designer. Why? Because some of those things aren't important. You only need to fill the boxes that are important for the user of the system. And that's not what we did with CMMI. And it's not what a lot of these yams are doing. They're just, it's a matrix, and some of them go to a 3-dimensional matrix and they fill in the box. And that's not lean. And so we really need to think about what are the crucial issues that we need to address to get the results we want to get. And we can list other practices as helpful, but I wouldn't go and require them. The other thing I personally worried about is in CMMI 1.1, the determining issue were the goals. The goal stated conditions that we believe needed to be in place for you to have success and create the capability at that level. The processes were guides to see if you in fact were achieving that goal. But you could have an alternate practice, or you could have a legitimate argument that some of the practices really didn't help the particular kind of project that you were running. That's okay, right? But now, as we shifted into Scampi and whatnot, all of a sudden, really the practice, getting every practice and or having an alternate practice became critical. And I think that's not as lean. It moved us away from the notion of the essential practices. I think it made the more costly, more burdensome, and I think that caused some people to drop away from CMMI. So we just got to think about those issues, and the future of maturity models needs to be, looking at that. That's why I'm going to build a meta model in CISC, so we've got something that can guide people building yams to come up with something that's reasonable and might actually provide benefit in actual use.
So we have time for one more question. So So Naramatsu has a question.
Yeah, thank you, Bill.
Hi, enough.
good
So
to hear.
how are you?
Yeah, I'm great, doing great. Thank you. So my question is already in the chat, and I think you have answered the first half of my question already, but just let me read it. Do you think the nature of a mature organization is described in this presentation, or something you have described in the past could be measured by a typical process assessment?
I think yes, the product thing is the one that's more challenging.
Yeah,
The reuse in product, that's more challenging, and we'd have to think about that. And it's not that as an assessor I would necessarily say, aha, you've done a lousy job of building microservices. What I'd want to see is that you've got a project in place to try to improve it, because I don't think you're going to purposely create junk. You're trying to improve it, you're trying to reconceive it, and the project is well run. You're realizing the problems. You may stop some parts of the project because they ran into dead ends. That's okay. And I'm not going to be the one that says this is a good product or a bad product. But I'd want to see that that's part of your continuous improvement initiative, because that's what certainly they did in the Six Sigma world. When they ran out of process improvements, they immediately shifted to looking at the product. Can I make it more manufacturable? Can I make it less likely to have defects, less complex, and what have you, more satisfying to the customer? So I just see that as part of what a mature organization does. It may mean that, yeah, we've got to help raise a new generation of lead appraisers. I think some of the ones out there now are certainly smart enough and experienced enough to be able to look at some of those kinds of things. I think some additional statistical exposure is not a bad idea. I think the over focus on control charts, and if you did the control chart exactly the right way, given that you've so heavily violated the assumptions of control charts and software, why worry about that? I want to worry about you're asking questions. Are you looking at that scatter plot and asking why this is here and that's there? Because you're going to come up with some valuable insights that'll help you make good improvements. So, yeah.
Yeah. So I I'm really interested in your maturity meta model, and I hope it has some aspects of this product looking
Oh, it will.
in your model, right?
It will.
And
Yeah, it will.
also, would you be interested in putting some material in that meta model on how to assess this maturity? Because
That
I
would
think
be
the
part
current
of it.
limitation is in the assessment method
Yeah.
rather than in
Yeah,
the model itself.
exactly. Yeah, true enough. And it would have to have some assessment components with it. And frankly, there is a standard that's going through OMG. Who knows? They might send it over to ISO. It's called SACM, is SSCM. It basically is a software assurance, but basically it's an evidence-based assessment method. But it starts with you building an evidence-based claim or an evidence-based case to defend claims you make about your software, or in this case, it would be claims you make about your process. I make claims I'm at level 4 against the following process areas. Okay, what's your evidence? Show it to me. I ought to be able to inspect it, and I could come on site and see if I really believe it. But you do the work in advance, and that I think is moving into a lot of areas, evidence-based assurance cases that then can be inspected independently to verify. And I think that would be the way to go, so that they're already really working themselves. They're on their own internal assessment to understand where they are and try to be fairly honest to themselves, and then bring somebody in to verify they got it right. And the role of a lead appraiser, one is verifying the evidence-based case, pointing out where it's got gaps or weaknesses, and frankly, in advance, maybe consulting with them to help them think about what evidence would you want to build to show that that you're actually implementing these process areas. And how would you go about doing it? How would you implement them, and what evidence would say that you have implemented them? So, and how do you get benefit from them? So it really makes you as much a process improvement consultant as a lead appraiser. And I think that would be a very good transition for this whole field, not just CMMI, but for the whole field of process improvement.
So, Bill, thank you very much. This has
Yep.
been just an excellent talk. And I'd like to thank Pat for sending the meeting announcement out to his friends. I will have the thanks to Paul Stackhour, who put the link to the TwinSpin website up on the in the chat. I will send an email out here shortly to all of you that says where the slides are and where the recording is, so that you can find it. And thank you very much for attending. And again, thank you very much, Bill, for a very informative talk and discussion.
My pleasure. And thanks everybody for attending, and good luck. Hope this helps you think about things.
Thanks very much.
Dick, I'll get it to you shortly.
Thank you.
See you, Bill.
Bye-bye, Pat.
Thank you.
Have a good
Thank
one.
you.
Enjoy
You
Florida.
See you, Pat.
By the way, the background on my picture there is from Eckerd College in St. Pete, where I went to undergraduate.
Well, there you go.
Yeah.
Majoring in drama.
Yeah. Well, I majored in mathematics and psychology, but I had a theater major when I graduated for all the performances I delivered.
There you go.
There you go.
All right.
Okay. Catch y'all later.
See you
Bye-bye.
next water cooler.
Thanks,
Okay.
everybody. Thanks very much.